Hello friends, today we will discuss about network theory. Here we often use two words. One is network, one is network and another is circuit. Okay, this is these two are very similar to each other. Okay, so first of all we should differentiate these two words. If I draw a circuit, if I draw a diagram, suppose this is a one resistance, this is another resistance, suppose this is a source Vi, it called VR1, it called R2. So suppose there is another resistance R3, this is the regional path. So if I draw this diagram, okay, if you closely look this, so this path is closed path, this path is closed path, so this is closed path, closed path, okay, and this path is open path, this path is open path, open path. When a diagram consists both closed path as well as open path, it called networks, network. Okay, when the network only consists only closed path, then it's called circuit. So in broader sense we use network. Okay, in limited part of this network is circuit. Okay, so all circuit, it must be a network, but all network is not a circuit. Okay, so in this lecture we will use both word network and circuit. So okay, and here you see that this is a network, this is a network. Okay, so if I apply some voltage here, we can get some response. Okay, we can get some response. This voltage may be a sinusoidal voltage, may be a DC voltage, or any others input signal. Okay, so it's called excitation. Okay, excitation. And for specific excitation, for a fixed network, we can get a response. Okay, so in network theory we get some three parameters. One is network, another is excitation, and other is response. This is the three parameter in network theory. Okay, when you know the network and excitation, so when your known factor is excitation and network, So these two part you already know. So for specific excitation, for a specific network, you can calculate the response. Okay, you can calculate the response. This process is called analysis, circuit or network analysis. This is called network or circuit analysis. Okay, this is called circuit or network analysis. But if your known factor is excitation and response. So for some specific excitation, you have to generate some specific response. For this, you have to design a network. You have to design a specific network. Okay. This here the known parameter is excitation and response. So you have to design a network. So this process is called synthesis. So this is called synthesis. This is called synthesis. So network theory can be studied in two ways. One is network analysis, another is network synthesis. Okay, so what is the network analysis? When your known factor is excitation or a network, only you have to calculate the response. This is called network analysis. But when your known factor is excitation and response, you have to design a network for specific excitation and response. You have to design some network is called synthesis. So these two study, one is analysis, another is synthesis. Okay, so network analysis is much easier, more easier than network synthesis. This is the basic part of our network theory. Okay, so when we will go to study network theory, we have to know some parameters depending upon the network theory. So this is called circuit element. So for network theory, we have to know some things. That one is circuit element. So when we design any circuit or network, we have to use some circuit element. That's why we have to know the what is the circuit element. Number two, when we use some signal, it may be a voltage signal, it may be a current signal, or it may be any other signal. This is called signal waveform. So you have to know signal waveform for network, for studying of network. So second part is network signal waveform. So first is circuit element, you have to know. Number two is signal waveform, you have to know. Number three, when we study a network, it can be studied in network can be studied in time domain or in frequency domain, because when we apply some AC signal, so AC signal is depend on time as well as frequency. So we have to know some tools, mathematical tools, so that we can transform a time domain function to a frequency domain function, or a frequency domain function to a time domain function. So this is called this for this network theory we have to know some mathematical tools so that we can transfer the time domain function into the frequency domain function, or a frequency domain function into a time domain function. For this mathematical tool, so you have to know some mathematical tools. Okay, this tools is tools. Okay, this mathematical tools is, one is Laplace transformation, Laplace transformation, transformation, and another is Fourier transformation, Fourier transformation. So this is the two mathematical tools. Using this mathematical tool, we can transform the time domain function into a frequency domain function, or a frequency domain function into a time domain function. Okay, so this is the three things we have to know to study network theory. So today I will discuss only this circuit element. Okay, what is the circuit element? So circuit element. Circuit element, all of you already know the resistance, the capacitance, the inductance, okay, or energy source, energy source. Okay, so this RLC does not contain any energy. It does not or do not contain any energy. Okay, that's why it's called a passive element. It's called passive element. What is this? Passive element. Okay, so circuit element can be classified as passive element. Passive element means this element does not contain any energy source. Okay, it's called passive element. When the circuit element is contain energy, that means it contain energy, is called active element. Okay, so circuit element can be classified as two ways. One is passive element and another is active element. Passive element is resistance, capacitance, and inductance, and energy source is called active element. And active element, that means energy source, is classified as independent energy source, and dependent energy source. Okay, dependent energy source. This is the circuit element. Okay, so all of you already know what is the resistance, what is the capacitance, what is the inductance. Here I will give some important part of the resistance, capacitance, and inductance. Okay, so first of all, this is resistance. Okay, what is the resistance? So any conductor, okay, if I apply a voltage, if I apply a voltage across it, across this resistor, then current will flow. But this conductor will oppose the current. This property is called resistance. So resistance is a property of a materials that oppose the current through it. Okay. So resistor, this is called R. So this obeys the Ohm's law. Ohm's law. V equals to IR. This is a linear in voltage and current relationships. This is the linear. This is voltage. This is a current. So if I draw this, it will be in this way. Okay. Suppose this is a theta, then tan theta equals to will be, this is a I and this is a V, so it will be I by V, and it will be 1 by I by V, that means it will be 1 by R. So inverse of the slope, so inverse of the slope is actually give the resistance, oh okay, so inverse of the slope actually gives the resistance. And resistance of a conductor is related by this law, rho L by A. This is the length of the wire, this is the cross section of wire, and this is the resistivity of the material. Okay, so resistance depends upon length depend upon cross sectional area, and the types of material, also the temperature. Okay, but the resistivity rho, this is the resistivity does not depend on length, cross sectional area, but it depends on materials, property of the materials. Okay, property of the material and temperature. Okay, temperature. And if I want to calculate the power, so power equals to VI or I square R. If I want to calculate the energy of this through this conductor, then it can be written as minus infinity to a function time t vi dt. In this way we can calculate the power. Okay, so depending, this is the primary parameter of resistance. Okay, now what is the capacitance? Capacitance or capacitor is a device. Capacitor is a charge storing device. Okay, so it can store charge. The ability of charge storing is called capacitance. The ability of charge storing is called capacitance. So Q proportional to V. So it will be Q equals to CV, and C is called capacitance. Capacitance. Okay. So C equals to Q by V. This is the formula of capacitance. Okay. So when it may be a it it store the charge, so it also stored the energy. So what will be the energy stored by the capacitor? It will be E equals to energy equals to half CV square, or it can be written as half VQ, or it can be written as half Q square by C. This is the formula of energy stored by the capacitors. What is the relation between voltage current relationship for capacitor? This is the voltage current relationship, অর্থাৎ V equals to C into V. So if I derivative dq by dt, so it will be dv by dt. Okay, so it is it can be written as I C dv by dt. So dv equals to I by C dt. If I integrate both sides, then V equals to will be 1 by C integrate I dt. Integrate I dt. Okay, I dt. So this is the minus infinity to something t. So in this way we can relate the voltage and current in capacitor. So energy stored by the capacitor is half CV square or half VQ or half Q squared C, and the voltage and current relationship it also V equals to 1 by C integrate of I dt. Okay. Now it may be a plate capacitor, parallel plate capacitor. Suppose this is a parallel plate. This is a one plate and this is another plate. Okay. This plate is this is because B, the area is A. Suppose this area is A, and the distance between this plate is suppose D. The medium between these two plates, suppose the dielectric constant is epsilon. Okay, so the capacitance of this parallel plate capacitor is epsilon into A divided by D. If there is a air or vacuum, then it will be C0 equals to epsilon 0 A by D. Or if we can express it in terms of relative permittivity, so epsilon 0 epsilon R into A divided by D. Okay, the value of epsilon naught is a permittivity at vacuum. So the value is 8.854 into 10 to the power minus 12 farad per meter. Okay, this is the value of epsilon naught. Now inductance. What is the inductance? Inductance So if I take a wire, conductor wire, and this conductor wire is wire is grounded in this way. So it actually construct a inductor. So for specific inductors, so it is a number of turns. So suppose this number of turns n equals to number of turns. Okay, so L is the inductance. Okay, S, suppose this is the area cross sectional, this is the cross sectional area. Suppose S is the cross sectional area, cross sectional area. Okay, this is the cross sectional area. And L, L length of the wire, length of the wire. This is the length of the wire. So this is a length L, this is a cross sectional area, and number of turns is L, N. Then the inductance L equals to mu 0 n square S divided by L. Okay, this is the inductance for this inductor. Okay, so here the relationship when current I is going through this inductor, if I is DC, then the initial portion, at the initial there will be a inductance, but after some time there is no inductance. So DC source cannot create inductance for long time. It's only inductance only arise at the switching on of the current and switching off of this current, because this the voltage across this where VL can be written as L di dt. So if there is no change in current through this wire, then the inductance will be 0. The voltage across the wire, the negative voltage or opposite voltage arise at this wire equals to 0. That's why the inductance will be 0. So for DC source, when we switch on the switch on at the time of switch off, so at the time of switch on and at the time of switch off, the inductance will arise, but for long time for DC source the inductance is not arise. Okay, for AC source inductance is always present, because for AC source there is a change in current. Okay, so the relationship, so magnetic flux equals to Li. This is the magnetic flux. Okay, this is this relation of L and I, and the energy stored by this inductor equals to half Li square. Okay, this is the half Li square, and this is the passive element of this circuit, that means resistance, capacitance and inductance. Okay, and there is a energy source. This is independent energy source and dependent energy source. So that is the energy source. So for energy source, this is first of all independent energy source. Independent energy source. For independent energy source, suppose this is a voltage. Okay, for ideal energy source, so this is Vi. For ideal energy source, the internal resistance is 0. Internal resistance is 0. So for ideal resistance, ideal energy source, the internal resistance is 0. So here is the V. If I draw the time versus voltage, so it deliver the same voltage through a long time. Okay, for ideal energy independent energy source. For practical energy source, practical independent energy source, there are some internal resistance. So for practical energy source, so the suppose this is a Vi, so it contain some internal resistance. So for this, it does not deliver same voltage through long time. This is time, this is V. So suppose this is Vi, so Vi will less compare at the first time. So when time is increased, the voltage will definitely decrease because of the internal resistance. So practical independent energy source, there is a internal energy, internal resistance. Okay, internal resistance, some finite internal resistance. Okay, this is the voltage source. For current source, suppose this is independent current source, independent current source, current source. Okay, for independent current source, suppose this is a independent current source. This is independent current source, this is AC. So if I use, this is DC. So this is a ideal condition. So ideal independent current source. So for ideal current source, there is no resistance. Okay, so it will be, this is I, this is T. So this is the I for ideal independent current source. But in practical condition, there is resistance parallel to this current source. Okay, for practical condition, so it does not deliver the same current at an instant of time. Okay, I. So for in this condition, it will be in this way. Okay, so it is the practical independent current source or practical independent voltage source. But there is a four number of dependent energy source. One is voltage. So one is voltage control voltage source. Voltage control voltage source. Suppose this is a suppose this is Vi. Okay, so this is a voltage. Suppose this voltage is, suppose voltage control voltage source. So suppose V plus or minus. Okay, this is mu Vi. Okay, This is mu vi. So this voltage, the output voltage is depend on input voltage. Okay, output voltage depend on input voltage. So for this condition, here is I equals to 0, I equals to 0. This is the vi plus minus. So this is the voltage control voltage source. There is another type is current control voltage source. Current control voltage source. Another is current control voltage source. So that is a current. So this is a, there must be a current. So this must be a, there must be a current. Here is the voltage vi must be 0. So here there some voltage. So this voltage plus minus, it is controlled by current. So it can be written as R M I. Suppose this is IN. So this is IN. So this voltage is called, so this is V output. So it is called current control voltage source. This is number 2. This is current dependent current voltage source. Okay, and here is the dependent current source. So current control current source. Okay, current source. How do you represent this current control current source? Current control current source. So there be a must be a line, there is a current. So this must be a I input. This is a V input equals to 0. There be a must be a current source. There must be a current source. This current is alpha of I in. Okay, this is the term V output. This is called current control current source and current voltage control current source. This is voltage control voltage source. Voltage source. How to represent it? It represent in this way. So this is a some voltage. So this is, so there is a V input and here is current must be 0. So this is must be a current source. Okay, this is current source. This current source is depend upon the input voltage. So it will be the GMV input. GMV input. So this is the output V output. Okay, so this is the voltage control voltage source. This is the 4 dependent energy source. Okay, now the network parameter. So network, it may be depend upon time or time, then and also the space. This is called distributed network. When the network parameter like voltage and current depend upon the space and time, it's called distributed network. If distributed network, if have any network and energy source or any passive parameter can be separated from the network, then this network can be called as a lump network. Okay, so what is the lump network? Lump network is the network in which we can separate the resistance, capacitance and inductance. Okay, this is called lump network. Time varying and time invariant parameter network. Time varying network means the networks depend upon time. That means the parameter, network parameter depends upon time. It's called time varying network. Okay, So this is the first lecture. So we will soon meet the next lecture. The next lecture I will discuss some elementary problem related